Okay, sure. Okay. Okay, so should be working now. Okay, so my plan for today is to fix an issue in BinaryBuilder.jl. So maybe I should give a short introduction about this issue in general. So building binaries, it's a very hard because there are a lot of incompatibilities. So if you go to the Yggdrasil repository on GitHub and you scroll down to the rootfs.md file, Elliot wrote a very long description about the problems that we face when building libraries for different platforms, and especially the incompatibilities due to several different reasons, like the standard C library, the standard library for C++ for Fortran, and also when you build a C++ library with GCC. Actually, GCC introduced in version 5 a different string ABI. So if you want to know more about this issue, you can follow this link and read. So basically, until version 4, that was the last version that didn't support C++ 11. Probably support for C++ 11 was introduced in version 4.9 actually, and GCC. So anyway, in version 5 they introduced this new different ABI to better follow the string ABI of C++. But this means that you can build at the same time a library for these two different ABIs. And the problem is also especially that the user can have on their side, they can have a different standard C library, C++ library. And so this means that when we build a C++ library that is exposing the string ABI, we need to build for both the old like C++ 03 version, and also for the C++ 11 ABI. Also libg Fortran, we have, I think, 3 different versions of libg Fortran that are incompatible one with each other. There is a link here, yes. So the oldest compiler that we use in a binary builder is a GCC 4.8.5, which has libg Fortran 3. And also GCC 5 uses libg Fortran version 3 and also version 6. Instead, GCC 7 uses libg Fortran 4 and GCC 8 uses libg Fortran 5. And also we have different versions of the standard C library in GCC. So we have all these versions that you can see here. So that's why when we build a library that is written in either C++ or G-Fortran, we have in many cases to use some tricks to make it possible to build for the possible platforms. And so, for example, if we go to Yggdrasil again, I think there was a recent pull request like this one. Sorry, just 1 second. Yes. So I think it was this pull request. Hello, hi. Yes, it's your pull request. Yeah, for example, this pull request was for a library called Higgs that used at the same point, at the same time, C++ and Fortran. And so after the compilation, the audit at the end of the building issued a warning saying this, that this library, or no, it was an executable, this Higgs executable contains the string ABI, and so this causes incompatibilities across GCC 4 and 5. And so to fix this issue, you have to build using both the two APIs. So in Binary Builder we have this function expand GCC GCXX string APIs, which basically tells to Binary Builder to build for both the versions of the C++ API. But also this library was using Fortran, if I remember correctly. Yes. And so there was also another warning saying that this library was linked to libg Fortran, and this causes incompatibilities across different versions of GCC. And so to fix this, we have to build for all the different versions of the libg Fortran standard library. And so yes, this library was actually in the end building, expanding both expand GFortran versions and expand CXX string ABIs. So these are two very common sources of incompatibilities. But yeah, there are also many other incompatibilities. So if you go again here, you will know more. Okay, so the bug that I wanted to try to address today was this one. That one. So in the wizard, when we request some dependencies, we have to make sure that we load the same dependencies, the dependencies of the same ABI as the build environment that we are in. Because, for example, the problem that Pablo was facing here, it's probably that he entered the build environment, but the libg4tron version was wrong, basically. So actually, I already fixed a similar issue some months ago, but not for the wizard. So this was just during the compilation when you run the script build.BinaryBuilder.jl. It was a bit complicated what I had to do here. Yeah, I had to modify a few files, 9 files. So I basically need to replicate the work that I did in this pull request also when we install the dependencies in the wizard. Okay, so now I will go to the text editor. So let's go to the wizard. So I'm looking for the function setup dependencies because that's the function that installs the dependencies that we need. I don't remember where it is, but we can grab it. Setup dependency. Well, I don't remember. Edit is in wizard. Okay. So it's in here. So okay, every time that here we install the dependencies, I need to tell not to use this platform variable, but actually something different. So I need to check what I did in the other pull request. So I had to modify the file auto build. Okay, so now I'm going to look what I had to do here. Okay, so here there is a description of the problem in the comment, so that when we get the dependencies, we want to match the same ABI in general, the GCC ABI, as the current platform. So this is a bit tricky because maybe I can show you in the terminal here. So the other time we saw the first live, we saw this function setup platforms, supported platforms, that shows all the supported platforms, but we can, as I've shown before, use the function expand CXX string APIs to get this list of platforms. So basically now you see the compiler API is explicitly specified. Instead here the word's not compiler API. So here when we just say supported platforms, we just use the generic API, because for example when we build the C library, we don't have to have a very specific API like for the C++ string API or the libg4tron version. And so here if we ask for the triplet for the simple supported platforms, the triplet is this, is made up of 3 parts and that's it. But when we expand, for example for the CXX string APIs, actually the triplet is not anymore a triplet, it's like a quadruplet or something like that. And so we have also here the specification of the C++ string API that can be either 6x03 or 6x11. And so for each platform, when we expand by the 6x string API, we have these 2 different versions. Instead, when we expand for the G-Fortran version, we have the compiler ABI specification with the libg-fortran version, so we can have a 3, 4, or 5, as we have seen in the table before. And if we get the triplet of this, so the triplet will be again the base platform without the ABI part, and then libg-fortran 3, 4, or 5. So actually we can also expand above the XX string ABI or the libg-fortran, and so in this case the triplet will be this string. And so remember that we supported 13 base platforms, but we have 2 different C++ string ABIs and 3 different G-Fortran versions. So in the end we support 13 times 6 different versions, 78, and in fact this vector, when we are expanding for both ABIs, we have 78 platforms. So when we have to build, like in the pull request that we have just seen, when we have to build for both platforms, for both different ABIs, we have to build 78 different tarballs. Okay, so for example, you can see your local platform key ABI in this way. There is this function in BinaryBuilder, but I think it's also in package binary platforms. So I think that if you don't have BinaryBuilder, you can just use this package to get the platform key ABI, and you can see the triplet, the full triplet, in this way. So for example, for my platform, the base triplet is this one, x86-64 Linux GNU. I have libg-fortran 4, and the C++ string ABI is version 11. Okay, so what I'm doing here in the text editor is to look what I had to do for all the pull request to basically get the concrete platform. Because sometimes we just build for all the supported platforms with supported platforms in this way, okay? But in this case, we don't know which is exactly the current full specification of the compiler ABI. And so that's why I had to use here some tricks to determine what was the current the concrete full specification of the compiler API in the current environment. So here the problem is that this function is defined, there is no function basically, so these operations to get the concrete platform is just done within this function, which is called autobuild. But instead I want to factor this operation out and put it in a function that I can then reuse within the wizard, for example. So this shards variable, it's used here, okay. So we'll probably take these lines out and define a function, for example, called function get concrete platform. We will see later what are the arguments that I need. So I will want to return the concrete platform. Okay. So one argument for sure is platform, because it's the initial value of the concrete platform. And then I also know that I want to here where I removed I want to do concrete platform equal to get concrete platform okay, so one argument for sure will be platform. Okay, so what I'm doing here is to initialize concrete platform with the current platform. And then I'm looking in the shards. Okay, so the shards is the collection of all the compilers that are mounted in the current environment. So we can have GCC, LLVM, also Rust and Go compilers. So shards I think will be a vector. And so yes, we are basically looking for the first shard that has the field name GCC bootstrap. And okay, so we are also checking. Okay, so what I'm doing is to determine the current ABI GCC compiler ABI from the shards, the list of the compilers that are mounted. So okay, and so if find first return basically nothing, this means if it's nothing, let me maybe rewrite this way, it's easier to read. So I'm looking for the first index in the list of the compilers that has as name GCC bootstrap, that has as target architecture the same architecture of the platform, this one, and libc library the same. Okay, yes, because I just want to make sure that okay, yes, I see. Because there can be multiple GCC compilers. Well, there can be at most 2 GCC compilers in the environment. The one for the target architecture, or also for the host environment, that is the Alpine Linux environment. So I want to make sure that I'm getting the GCC bootstrap compiler for my platform. So, for example, when I build for macOS, I want to make sure that I'm using the same architecture and the same C library, and not instead, for example, the architecture and the C library of the host environment. Here I'm interested in the target environment, the platform for which we want to build. Okay, so if we find this GCC compiler in the list of the compilers mounted, then we get the preferred libg Fortran version, comparing our current platform and the shard corresponding to the GCC, basically the GCC compiler for the given platform. So basically this preferred libg Fortran version is trying to determine which is the common libg Fortran API between platform and the GTC compiler in the current environment. Then it's doing the same for the CXX string API. So there is this function preferred 6x string API that is comparing the 6x string API of the current platform and the compiler to determine which is what we want to do. And then is setting a concrete platform using this new 6x string API and libg Fortran version that we've just determined. Okay, and so we return a concrete platform. So the only thing that we have to do is to get the list of compilers as argument. So here I will add also shards, and when I call the function, this will be shards. So basically now what I did was just to factor out what I was doing inside of this function into a new function that I will hopefully be able to reuse also for the wizard. So yes, to be honest, the wizard is very nice, and it's, I think, a very useful tool to get started using Binary Builder, but it's not as powerful as directly using the BinaryBuilder.jl directly, because in the script you have much more control. So sometimes it's hard to get all the features that we have in a build script also into the wizard. So if you start using Binary Builder, you will find that the wizard is not on par as the experience of using the wizard is not on par as using the build script. So now I'm trying to fix this annoying issue. So here we have the list of all the calls to set up dependencies. They are all in this file called interactivebuild.jl. So yes. So basically I will need to replace this platform with the concrete platform that I will need to determine in some way that I still don't know how. So I want to go back here. Yeah, for example, let me show you. So when we call directly the build.jl script, this function autobuild is called, and there is now this line setup dependencies, and the last argument is concrete platform, which is now the full specification of the platform, including all the compiler APIs, so the C++ string and the libg Fortran version. So in interactive build, the trickiest part will be to get the list of compilers, and I don't know how. So the wizard remembers what you have done by looking to this mutable struct called wizard state. So in all the steps of the wizard, it records what you've done. So for example, when you start, you're asked for the source URL or the dependencies, the compilers, the preferred GCC version, the preferred LLVM version, and so on. So for sure I will look into this state, wizard state, but I'm not sure that I have the same information as auto build here, because basically this compilers field in the wizard state, if I remember correctly, is just the list of compilers like C, Rust, Go, or something like that. I can check in the tests. We have a test about the wizard compilers, yes. So state.compilers, for example, can be C, this vector of C, Rust, and Go. These are symbols corresponding to the languages that we want to build for. Actually, C stands for C, C++, and Fortran. Because basically we need a single compiler for all of them. So the problem here is that I don't have all the same information that I want to use, and I will need to come up with something. So this is the fun part. Understand the information that we have within the wizard and try to see okay, so this is actually useful. If we go back to the autobuild.jl file, the shards variable is set using this choose shards function. So if I go to the terminal, I can maybe experiment a little bit. So we'll do this. Okay, so if I run BinaryBuilder.choose shards platform, okay, this is exactly what I wanted. So maybe we can make it So this function choose shards returns the list of the compilers that we can that we want to use, and the only argument is platform, which is an information that you actually already have. We can also have additional keyword arguments. Which probably, at least for some of them, we have. So the keyword arguments, yeah, the doc string is not updated because here there are some additional keyword arguments. Okay, that's okay. So compilers, we have it. Prefer the GCC version and prefer the LLVM version, we have them. The only thing that I don't know is the bootstrap list, but maybe we can ignore it. And Yeah, let me try. So my initial guess will be doing something like this: shorts equal to preferred GCC version. Oh. Preferred LLVM version. Compilers equal to state compilers, I think. So let me check again what we have in the wizard state. So yes, we have compilers, preferred GCC version, and preferred LLVM version. Okay. So actually I can already show you what's the problem. So if I did a mistake here. Okay, so let me just comment this. Restart. So now I want to enter the wizard to show you what's the problem before trying to fix it. Because there is an easy way to check it. So let me, I don't know. So I just need any okay. So run wizard. Okay. So I don't really want to build something. I just want to enter into the wizard environment. So I just copied a URL of, for example, a libcurl. Yeah, also supported platforms anyway will go out. Okay, additional sources, no. Yes, I want compile support libraries. So this compile support libraries is a GLL package that is providing some libraries for the compiler. No. So for example, it provides libg Fortran, the standard C library for GCC, and some other libraries like that. Okay, so now I don't really want to build anything, but just to show you this. So echo target. So now basically we are trying to build for this platform. So this is what is called the compiler API agnostic, because it doesn't know anything about the specific API that we are using. But we have also in the environment, we have another variable called full target. Okay, I thought this had the full specification, but it doesn't. Okay, anyway, so this is assuming basically that it's my environment, and as we have seen before, I had libc Fortran 4, but if we go in libdir, we should have libc Fortran 3, no 5. Okay, yes. Yeah, okay, so anyway, it's a different version, it's a wrong version of libc Fortran. So by default, what the wizard did was to just use any where is it? Chat. Just want to use any compiler, any compiler API version of the compiler support libraries package, because it didn't know what version to build for. So the problem is that it installed this version, libc Fortran version 5, but actually it should have used libc Fortran 4. So fixing the issue would mean that when I ask for compiler support libraries, it would install libc Fortran 4 in this environment, so that it will match the compiler API, or the current compiler API, that actually we should be able to see, for example, in this directory. Nothing in census root. Should be somewhere here. Maybe 64. No, it's not this one. Okay, yes. So in this directory, you can see, okay, libc Fortran. So this is the actual compiler. These are the libraries in this directory. There are the actual libraries for the current compiler. And so, for example, you can see from here that libc Fortran is version 3. But instead, the library, the compiler support library, was installed with a version 5. So there is this mismatch between the actual version of libc Fortran for the current compiler and the version installed of the dependency. And so this can be a problem. When you try to build, you will find a problem, because there will be this mismatch between the APIs. Okay, so this is the issue. So let's now go back to try to fix it. Okay. Okay, so this is useful because I can see. Yes, okay. So I'm looking to the content of the state Oh, this is very long. Ah. So I used so when you exit from the wizard, the state is returned as exit value, and so I took it in this way. So now I'm inspecting the contents of the state variable. I used this dump function to dump the fields of the state, but it's very long, so probably I will just look into some of them. But anyway, this is useful because I can do binary builder, choose shards, yeah, for example this one. Okay, so I will now try to call correctly this function choose shards in it was interactive build here. Choose shards. So I need to find where this function is defined. Probably in rootfs. Let's see, choose. Yes. Prefer GCC version equal to state. Okay, so then there is still an error here. That I will fix later. Preferred LLVM. Sorry. Okay, so this function should be correct. Okay. So these shards should be correct. So if I do concrete platform equal to get concrete platform and shards. This should work. Let's see if it works. Okay, so this is called indifferent functions. Okay, so if you notice here, actually I could yeah, I could probably simplify the function and then get because if you notice here, basically shards is anyway determined by platforms, so I don't really need to define shards and pass it as an argument here. So what I would need is to get these preferred GCC version or LVM versions and compilers here. But for the time being, I don't want to change this. So, I don't want to change this, so I will stick with the current definition of the get concrete platform. And I will need to reuse basically this one several times. And I just moved the definition here. This is the concrete platform. So I will copy these lines. The next function that is going to call setup dependencies. This will be concrete platform. Oh, oops. Okay, so this will also be concrete platform. This will be concrete platform. Okay, so I think that I fixed it in probably all places. And I can already recall the wizard and see if this was fixed. So the wizard is nice because it saves the state into a file and it will read back the file from the disk, so we can resume the previous run of the wizard. So now I can do this, and yes! So now the dependency was installed with the version, the compiler support libraries was installed with the version of libg4.3, which was exactly what I wanted to do, because the current compiler, we can check it here. Target lib64, I think. Yeah, the current compiler is using libg4.3. So I think that the issue is fixed now. The only thing that I could do is to slightly improve the fix, like avoid some code duplication, maybe. Let me see if, for example, I can define a new method here. So what I'm thinking to do is to define a new method here, like this. Oops. and compiler is equal to nothing, and basically define shorts. Well, I can just copy from. So first of all, let me save the changes that I did. So we'll put all these changes to the staging area, and this function definition, and this. Okay. Because I'm pretty sure that the changes now are correct. What I want to do now is basically do this. I will call get concrete platform shorts. Can return it. So okay. So my idea is to define this new method that I can call in the interactive. It's called interactive.build.jl file. So I can do, instead of that, well, I can do this. Oops. So this will be basically the same thing, I think. Okay. Okay, so let's see if it works. Yeah, okay, so the good point is that these fields, compilers, preferred GCC version and preferred LLVM version are always set. So I don't really need to make sure that in the wizard, when go on in the wizard, these fields are always set. So I don't really need to take care of the nothing case. Well, maybe I should. But yeah, for the time being, it should be good enough. So okay, let's try again to enter the wizard. So we can resume. And yes. Okay. Yeah, also the lib standard C++ is version 6.0.19 and it's also here. I don't really know why there is also 26 to be honest here, but it's okay. But yeah, I was most interested in fixing the libc fortran, which now should be correct. So unfortunately, I don't think there is an easy way to test the fix that I made, because the wizard is a bit complicated, and fixing this is yeah, it's not super easy. Even testing this, it's not super easy. But okay, I'm happy enough about these changes, so we'll save all of them. Maybe I will add some more comments here, like adding a doc string, which is always good. Platform is a platform, and short is a vector. What vector is this? Compiler short. So let's say return the concrete platform. Based on the compiler API of the GCC compiler API. The shorts. Okay. Also another docstring here. So this is a platform. I can leave these keyword arguments without type. I don't really care, but maybe it's better to mention them. Okay. Yeah, I just wanted to check what are shard was in rootfs. Oh, okay, so this must be a number. Okay, well, anyway. Yes, it's Emacs. Yeah, someone was asking if this is Emacs. This is a recurrent question during my streamings. So So let's go back here. I wanted to fix so I just put a reference to choose shorts, so it's easy to understand what I'm saying here. Based on the basic compiler API, the set of shards is chosen, right? 2.0. No, not chosen, sorry. It's the chosen one. Okay. So I think I can just stage all the changes. And yeah, I'm happy enough, and I can in the wizard matching the current compiler API. Okay, I can push, and now I can open the pull request. So if you go here, I can just do this. Yeah, and maybe I should reference the issue, which was a 702. No, 105. Okay, that's it. Okay, so we will find out if the tests are passing. I didn't add new tests, but at least we will make sure that we are not breaking the existing tests. So yeah, unfortunately BinaryBuilder is really a mess for testing, and Elliot did a really hard job to make it possible to test some parts, but in general it's very hard because it's also very, especially the wizard is very interactive, so replicating all the steps is quite difficult, and even though there is the possibility to test somehow the interactive part as well. Okay, so I will say that I finished what I wanted to do, but I don't have anything to do this afternoon, so I will try to do something else. If we want to stay tuned in, you're welcome. Otherwise, thanks for watching. So what I wanted to do was to try to basically make Avik happy. Because I wanted to have CMake version 3.16 in the build environment. We currently are providing CMake version is 3.13. So what I wanted to see if to check whether I can build within this environment CMake version 3.16, but only for the host. So this should be somewhat easier, because this is just needed to build. It's not something that we want to provide for the target platforms. Okay. So I have no idea where I am here. So let me go to temp, create CMake, well, whatever, CMake directory, and yes, start. So now I'm just starting an environment, a shell. It's not within a wizard, it's not nothing, it's just I wanted to enter a shell to try and build CMake in here, and if it works I will somehow add the instructions somewhere. So download. We can try the latest version maybe. So let me go back to the text editor. Okay, so type CMake. So we only want to build for the current platform, so configure should be enough, probably. So in the end I will need to do something like this. So in Yggdrasil, if you go to the 0 rootfs directory, in rootfs, so this is the environment that is provided within the builder, the builder environment. It's our root file system. And so my idea in the end is to add the instructions to build CMake that we are trying to do here, to add the instructions here somewhere, because for example we do this for Mason. Yeah, for example here we are building Mason because we wanted to have a recent version of Mason. Mason is another build system like CMake or AutoConf. So probably in the end we will need to have some steps to build CMake, like this one in here. But this is just a quick test to make sure that compilation is successful, or we need to do something special, I don't know, we will find out. So I only run configure and it's already building. So maybe this was not the right thing to do. Okay, let me start from scratch. Parallel equal to let's say 4. So this should make this parallel. Okay, yeah, it's going a bit faster now. Okay. Okay, we need OpenSSL. How do I pass it? Okay, so maybe I will do something more straightforward, like because I don't want to use this rootfs build script because it's quite complicated. I just want to build cmake, but maybe I can try to use it. Oh, there is already cmake here. Okay, so this is interesting. There is already a cmake. What I want to do this. And I want version 3.16. .1. Okay, so a common issue when trying to build oops no, the address is different. So a common issue when someone tries to build something for BinaryBuilder is to determine how to determine the second argument. So here this should be now an archive source. So this archive source is a type of the source. The first argument is the URL, and the second argument is the SHA 256 hash. And we can determine the hashes in this way. So we'll basically download the tarball to standard output, in this way and compute the hash. So this is something that I do quite often. Okay. So the trick is this. It's also written actually in the binary builder documentation. So you can just download the tarball to standard output and then pipe to SHA-256 sum. Okay, so now I can build this. So let's see if this one works. Which will be the ideal solution. So I can go here, CMake. Oops. Let's go. So this is wrong. Oh. Using BinaryBuilder. All right, libc. Okay. Okay, so we can try again. So it's better to do it this way because I could set up the dependency also. Like here, the dependency OpenSSL JLL. So let's see if this works. So again, this is just an attempt to see if we, the problem is that the CMake can't be cross-compiled, which is very ironic, or anyway it's very hard. So far we could not manage to cross-compile the CMake, but at least the native build should be relatively easy to do. So let's see how it goes. Okay, it looks like that is going on. That's good. Didn't complain so far. Maybe it will have problems at the end. Oh, it looks like it worked. This is great. So, yeah. Okay. So I think I can so you see make 73.17.1. CMake upgrade CMake to version 3.17.1. And the audit is stuck, which is not great. But yeah. Yeah, anyway, we'll probably push and see how it goes on our CI service on Yggdrasil. So maybe you notice that here I've added 2 other platforms, because these are, if you remember, the 3 platforms for which we can do a native build. Actually, theoretically, there could be this 4th platform, the 32-bit Muzzle Linux, but we have a problem in this platform, so that C++ and Fortran programs can't be actually run. So this is a C++ program. If I remember, CMake should be a C++ program. What is the scroll bar? Yeah, you see it's built in CXX objects. So yes, this won't work anyway. Okay, this is stuck. I will stop and I will go to Yggdrasil to open the pull request. So yes, if compilation is successful, we can add this step to this file. Okay. So yeah, that's it, I think. Create pull request, maybe if there is no queue, we can also follow we can follow here. It should start in a few seconds. Okay, so I downloaded the source and now should start compilation for the 3 platforms. So there is someone else still watching. I hope that you didn't get bored. But I think it was productive this session because I was able to fix an issue. I probably managed to build the latest version of CMake, do a native build of CMake, which can be useful for building XGBoost. Yep. So this should be like the initial configuration on the build where it's checking that all the dependencies are there. But then the actual compilation will hopefully be a bit faster because that one can be done in parallel. Yeah. And so on this machine, if I remember correctly, we're using 8 parallel jobs. Mm. 94, 96, so probably it's almost done, at least with compilation. Yes, so now it's installing the products, and the audit should start shortly. Yes. Okay, let's see the other jobs. How did they go? Yeah, also this one finished, and audit started, and also this one. Okay, cool. Okay, I think I will stop now because basically compilation was successful. So now audit will take a bit, but it's okay. Okay, so thanks again for watching and staying with me so far. Have a good day. Bye bye.